Today we are going to solve problems on DFA, the various methods of constructing the DFA. So the first question will be focusing on, will be accepting the set of all strings over the length 2, and the second question will be accepting the set of all strings that contain 110 as substring, and the third one, accept any strings over the alphabet 01 that does not contain string 110 in it. So these are the three questions that we are going to focus about. So moving on to the next question. So the first question is, how do we design a DFA that accepts set of all string over alphabet 01 of length 2? So first and the foremost step, whenever you're getting this as a question, so what you have to do is you have to write the elements of that particular set. And in the previous video, I have mentioned the power of alphabets, that is sigma raised to 0. It will be a set of all strings of length 0. Sigma raised to 1 means set of all strings set of all strings of length 1. Sigma raised to 2 means set of all strings of length 2. Sigma raised to 3 means set of all elements of length 3. Likewise it goes. Since our question is about length 2, so it will be sigma into sigma, that is 0, 1 into 0, 1. So it will be concatenation of zeros and 1. So 0, 0, 0, 1, 1, 0 and 1, 1. So these are the elements, and there is no particular order in which it has to. It can be neither form 0, 0, 0, 1, 1, 0, 1, 1. So it's not a problem. Now, in order to construct the state diagram, we should have the initial state. Okay, so 0, I should, if I am getting an input symbol Q0, I should move to the state Q1, and from Q1 I should move to another state, so 0, 0 transition. This should be accepted, so I should make that as a final state. Okay, so fixing it up. So this is my final state, this is my second state, and this is my initial state. Okay, now we'll draw. So this is my initial state. So initial state will be represented with an arrow next to the state. So Q0, I have next state Q1, and my final state is Q2. Now, if I am moving from state Q0 to Q1 with 0 as the input symbol, okay, Q0 with 0 as the input symbol, I reached Q1 state, and from Q1 with 0 as an input, I reached Q2. So this string is accepted. What if it is ending with 1? So I should put a comma and give an input symbol. So 0, 1, it is accepted by the Q2. Now, what if it starts with 1? So I should put comma 1 over here as well. So 0, 1, move to Q1, 0, 1 transition. So according to the DFA, construction of DFA, we need to focus on three things. That is, there should not be more than one transition. That is true in this case. For Q0 and Q1, there is no more than one transition, and each state consume each input symbol. That is also done. So two steps of the DFA done. But what in the case of Q2? Q2 doesn't consume any of the input symbol 0 and 1. So we need to give 0, 1 input symbol for Q2. So if I am giving a cyclic loop, what will happen? It should go beyond the length 1. Beyond the length 2, right? So if I am focusing on length 2 means 0, 0. After 0, 0, I should not accept any occurrence of zeros or any occurrence of 1. So I should not, I am not supposed to use a cyclic loop. So what is the next thing? So there comes our dead state. So we give this transition to another state and we call it as dead state. What do you mean by dead state? It will accept only incoming. There is no outgoing transition in that state. So we represent a dead state with a QD. as Q2. So whenever extra 0 or 1, I'll send it to the dead state. Okay, so it will not accept any strings rather than of length 2. And what about QD? It doesn't consume all the inputs of the input symbol, so I should go for a self loop 0, 1 over here. Okay, so first thing, you need to write the elements of the particular string. Then you check you design the DFA. Now the second step is, the third step is, you need to check whether our machine that we have designed is right or wrong. So in this case, I am going with a string input, sample input string. Check with the sample input string. So sample input, let the sample input be sample input, let the sample input be 1, 1. Okay, if the sample input is 1, 1, so from Q0 with 1 as an input symbol, I am moving to the state Q1, and from Q1, if 1 as an input symbol, I am moving to state Q2. And here the Q2 means, or if I am putting this, means it would be hard to understand. So if I'm using Q2, this is my Q2. If I'm representing Q2, this is my final state. So Q2, I have reached the final state. Okay, I have reached the final state. And if I reach the final state, means that string is accepted. String is accepted by the machine. Now, suppose if my sample input is sample input, which is of length more than 2. So it can be 0, 0, 0, 1. Okay, 0, 0, 1. Let it be 0, 0, 1. So I'll go with green now. So I'll start with Q0. Okay, Q0 with 0 input. I reached Q1, and Q1 0. I reached Q2, and Q2 0. I reached QD, and QD 1. I am in the same state QD. And here QD is a non-final state. QD is a non-final state. Since it's a non-final state, means string is rejected by the machine. The string is rejected by the machine. Now, how do we understand that whenever it is a final state, it is according to the finite automata physical representation, we have all the states in the input. Each cell, it has got a tape head, a finite control, and all, right? So we start from the initial state. So the scanning start from left to right. Okay, so this is my input. So it start from left to right. And once I reach the last digit, I'll see whether it is the final state or not. If I am not in the final state, means that string is rejected. If I am in the final state, means that string is accepted. Okay, the first thing you need to identify the elements in the string. Second, construct the DFA. Third, you need to see whether when you construct the DFA, make sure that it should not have more than one transition. Each state should consume all the input symbol. It does not have any epsilon transition. And verify using with the sample input. Once that is done, that is the construction of the DFA. Okay, now moving on to the next thing, that is next question. Here you have to see the, you should read between the lines. Design a DFA that accepts a set of all strings that contain 110 as a substring. So you need to identify all the strings that contain 110 as a substring. So it can have 0 in the beginning, and followed by 1, 1, 1, 0, 0, and it can have 1, 0 at the end. So this is the sequence. I should select the color. So, color. Oh, I use the highlighter. Okay. So 110. Okay, 110 substring. Now it can be 1 followed by 010 1 So there comes another set of substring. Okay. So these are the sample inputs that we are going to analyze. Okay. Now we need a transition diagram, right? So we have an initial state Q0. This is normal shape. Okay. Go for 0. Okay. So initial state. So 1 0. If I'm giving 1 as an input, I should move to next step. So Q0, Q1, another 1 transition, then 2 0 transition and 0 transition. So Q0, Q1, Q2, Q3, Q4, and Q4 should be the final state. So this is my initial state, 1 transition, another 1 transition, 0 transition, 0, and it should be accepted by the machine. Okay. This should be accepted by the machine. Now we'll draw the transition diagram. So this is my initial state. So I represent this as a Q0, Q1, Q2, Q3, and Q4 state. Okay. So Q4 state. So with one input transition, I reached Q1. The next transition I reached Q2, so 1 1, and the next transition to 0, Q3, and the last transition Q4. Now we have to look what if it starts with 0, what if it starts end with 0 1. So there is no criteria that it should not start with 0 or 1. There is no limitation with whether it can start with 1 or 0. So that condition is not. Whatever the condition is, you have to accept all the strings that contain the substring 110. So I can go for a cyclic loop 0. Why? Because if I am starting with 0, there is no disorder in the sequence of 1100. So that is accepted. And what if it is end with 0, 0 or more occurrence of 0 comma 1? No problem, because only thing we have to focus is substring 0 1100. So if it starts with 0 1100 followed by 0 and 1, it is fine. So if my sample input is 0 1 1 0 0 0, then 1 0, it is also accepted. That is a substring. So this is accepted by this string. So this is accepted by the string. So I'll put a tick. This is accepted by the string. Okay. Now I am in Q1. If I am getting a 0, will I able to maintain the sequence? No. So if I am getting an input symbol, if I am getting an input symbol 0, I should change to the Q0 state. I should move to Q0 state. I'm moving with 0 as the output symbol. Okay. Okay, if I am moving with 0 as an input symbol, I am in Q0, and in a way I can save the sequence manner 1100. Okay, that is also accepted. Now, what if this particular string doesn't hold? That is, if I'm getting 0, 0, 1, suppose if it is 0, 0, 1, and if I'm getting a 1 again, if that link is not working, I should go for a cyclic loop of Q2. And it satisfies the DFA condition that Q0 has got the input symbol transition with Q0, 1 transition to Q1, Q1 0 transition to Q0, Q1 1 transition to Q2, and Q2 has got the self loop in 1 itself, and Q2 with 0 is also there. Now, what if Q3, if you lost the sequence 0 over here? If you lost the sequence over here, we'll start again with the Q2. If you lost the sequence in Q3 with 1 as an input, I should send it to Q1. Why not with Q2? If I'm giving to Q2, it is having more than one transition. So that is not, that is violating the DFA rule. So I'm sending the Q3 with 1 as an input to the Q1 state. So in a way, I am accepting Q3 with input symbol 1 and input symbol 0. And thus we reach the final state Q4. Now let's see whether this string is accepted by the machine or not. So we'll start with Q0 with this condition. So Q0, this is what we are going to do. Q0 with 0 as an input symbol, I am in Q0. Okay. And with input symbol 1, I am moving to which state? That is Q1. Okay. Now Q1, so I have 0, 1, then again 1. Q1, 1 means I am in Q2. And Q2 with input symbol 1 means I am in where? Q2 symbol with 1 means I am in Q2 again, and 2 occurrence of 0. So Q2, 0 input symbol, I am in Q3 state, and with Q3 with 0 input, I am in Q4. I am in Q4 state. So 0, 1, 1, 1, 0, 0 substring is there, and from Q4, if I'm having 1, I am in Q4 because it's a self loop. I'm staying in that state itself. I'm moving with again a 0. I am in that state itself. And from again, I'm moving with 1 as an input symbol. I'm still staying in that final state, and that string is accepted. This is the final state. This is the final state, and string is accepted. String is accepted. Now, what about this string? What about this string? Okay, 1 0 1 0 1 1 0. So 1 Q0 with 1 input symbol, I reached Q1. Q1 with 0 input, I reached Q0. Then from Q0 1 input, I reached Q1 again. So these things are satisfied. So 1 0 1 is occurred. Now Q1 with 0 means I am again in Q0. Okay, Q0 with 1, I reached Q1. Then Q1 with 1 again, so I reached Q2. Q2 with 0, Q3, Q3 with 0, Q4, and last 1. So this also is accepted. So these 3 string is accepted by the machine. So this also, these 3 strings are accepted by the machine. Okay, so in a way we are finding all the strings are accepted by the this machine. Now moving on to the next question. Here we are going to design the same DFA, but here we are focusing any strings over the alphabet 0, 1 that does not contain string 110. You are not supposed to have 110 in that string. So for example, what will be the strings then? it can be 0, it can be 1, it can be 001, it can be 100, it can be 110, or it can be 1010, 10, it can have 10101111, or it can be 0000001. So these are the set of strings. Okay, it can have 0, it can have 1, it can have 00110, like that it goes. So we'll do this thing. And one more thing is there, we can from the previous example, from the previous question, it was saying that all the final state in that example, like the technique to find the string that does not contain 110 is flipping the state. Okay, this is the thing that we have to apply when such question comes that does not contain string 110. So we need to flip the chain. So initial thing is you need to find which construct a DFA that accepts 110. Then after you find construct that DFA, you need to flip the state. So the same states and the same transition, only thing is you need to flip the change. So final state will be when you flip, mean the final state will be the non-final state. Final state will move to non-final state. Okay, and non-final state will be final state Okay. Okay. Now, if you have moved back, we can see that Q0, Q1, Q2, Q3 are non-final state and Q4 was the only final state. So, we can write that Q4 change to non-final state and final state, non-final state. Q0, Q1, Q2, Q3 are final states now from the previous question. So whenever such questions come, you have to find the construct a DFA that accepts that as a string. Then you have to flip the change. That is the only thing you have to do. There is no other transition or no change in the transition. So we have 4 states, right? Q0, Q1. Oh, that should be a final state. So 1, 2, 3, then Q3, Q4, Q3, and this is Q4. Now rearrange. So initial state, this is your Q3 state, this is your Q, and this is your fourth state. Okay. Now, initial state and the final states are the same. So this is Q0, this is Q1, Q2, Q3 are the final state, okay, and Q4 the non-final state. So you will not use the concentric circle over here. Now there is no change in the transition diagram, so it is 1, 1, 0, 0, and if it is a cyclic loop with 0, and if I'm having 0, means I have to send it to transition state Q2, Q0, and Q2 will have a cyclic loop of 1 over here, and Q3, if one transition is there, I should move to Q1, and Q4 should accept 0 and 1. Consume input symbols 0 and 1. Now we'll see whether the whether it can be checked, whether we verify that that string will check this as a string. So Q0 with 1 as an input, I'm moving to Q1. Q1 with 0, I'm in Q0. Okay, so 1 0. From Q0 with 1 as input, I'm in Q1 state. No, 1 0 1. Okay, I'm in Q0. Q1, I'm in Q0 with 1 input, I'm in Q1. Q1 with 0 input, I'm in Q0. Q0 with 1 means I'm in Q1 now. Okay. In Q1, I'm checking for an input symbol 0. So I am in Q0 again. So 1010 is completed. Now Q0 with 1 input symbol, I reached Q1. Okay. Again from Q1, I'm checking for 1. So I reached Q2. Okay. And Q2 has got 1 input symbol, I'm in Q2. Okay, so 1010, and how many occurrence of 1? 3 occurrence of 1 completed. So Q2 1, the 4th occurrence, I'm in Q2 again, and from Q2 with 1 I am in Q2. So Q2 is a final state, so it is also accepted. So 1 0 1 0 1 1 1 1 1. So I reach the final state. This is my final state. So I reach the final state. So the string is accepted by the machine. Final state string is accepted. String is accepted. So it does not have any substring 110. The easiest string checking can be done with this one. If it is 0, 0 is accepted. If it is 1, I am in Q1, that is the end. 0, 0, 1, that is also accepted. This one is also accepted. 1, 0, 1, 0, 0. So I up to when I reach Q0, that is also accepted. 1, 1, 0, I reach Q3, so that is also accepted. So these are the various methods in which you can find where the construct a DFA. So we discussed about construction of DFA with respect to these conditions. One with respect to length 2. So if there is an extra extra digit coming, we have to send it to the dead state. What does it mean by dead state? Mean it has only incoming transition. There is no outgoing transition. So that is an end. So if you have it, when you traverse from left to right, if you reach the final state, means that string is accepted by the machine. If not, it will be rejected. Okay. And the next question that will be discussed about how to construct a DFA that accepts all substring 110. Okay, we constructed the substrings. Okay, we identify some of the sample inputs, and with that we check whether we have reached the final state. If we are reaching the final state, means that string is accepted. And for the next case that does not contain string 110, the easiest tip is the using the flipping of states. And when you flip the state, means final state will be non-final state and non-final state will be final state. So from the above example, we found out that Q4 is a final state, so I have to switch that to a non-final state, and Q0, Q1, Q3 are the final state from the previous question. So we change Q0, Q1, Q2 at the final state and Q4 as the non-final state, and we check whether each state has got the consumed input symbol zeros and 1. So that is also satisfied. So and see whether the corresponding input symbol have been accepted by the machine. If so, the string is accepted. So this is the end of our DFA problem set 1, and the next class we'll be discussing more of past paper questions. Hope you understood, and if you have any queries, please feel free to comment on the comment box so that I can have a check on it and explain in the next class. Thank you.